Question 3a. Define Le Chatelier principle. Okay, this one is very easy definition. If the conditions of a system in dynamic equilibrium are changed, the position of equilibrium will move or shift to minimize the change. Okay, so for example, the conditions, it can be concentration or temperatures or pressure. Okay, let's say we use these equilibriums as example. So dynamic equilibriums means the rates for the forwards and backwards must be equal. And the equilibriums can be established in a closed system. So let's say now we increase the concentration of this iron 3. So the equilibrium will try to reduce this iron 3 concentration by moving to another side, means the right hand side. So this is the principle. The system always try to reduce the change, the conditions that being changed, right? So hope you understand, right? And it's of course it's very easy. For the part B, reaction 1 describe the reversible reactions between the iron 3 and which is yellow, and the colorless SCN negative to produce this complex ion or this cation. So the reactions enthalpy is exothermic here. So now a mixture of iron 3 and the anion and this cation is at equilibrium at 20 degrees C. The temperature of this mixture increased to 50 degrees C and allowed to reach equilibrium. Okay, so now we need to compare the temperature. Initially is 20, now increased to 50. Means temperatures now is getting higher, and the equilibrium try to reduce the temperature by moving backwards. Because moving forward is exo, moving backward is endo. When it's moving backwards, so it will absorb the heat that increase. That's how the equilibriums reacts with the change. Now the question is, deduce the change that occur, if any, in the equilibrium mixture at 50 degrees C compared to the equilibrium mixture at 20 degrees C. Okay, change in appearance. So we need to know the color, because on the left hand side is yellow, right hand side is red. And we know that when temperature increase again, the equilibrium will shift to left. Means the red color will be lesser and the yellow color will be more. So the appearance is more yellow produced, or we can say less orange, because when the yellow and red mix up, it will be orange, and when more yellow form means less orange. Okay, it's better for you to say more yellow produced. Okay, the second part, change in the relative concentration of this FeSCN2 positive, means it's a product here. We know that higher temperature again is shift equilibriums to the left hand side, means the concentration of these the products will be lesser. So you just say it's lower. Change in the value of the Kc, because the temperature now is increases, the Kc confirm will change. So we know that the concentration of the product is lower, and the concentration of the reactants will increase, will be more. So using this Kc expression, so we know that the concentration of the product is getting lesser, and the concentration of the reactant now increases. So means Cassie will be lower. Right. Part C. In another experiment, equimolar amounts of iron 3 and the SCN negative are mixed together, allowed to reach equilibrium. Total volume is 25 cm cube. Okay, we need to use this one for the mole calculations later. So reaction 1 is we just discussed, right? So this equilibrium. At equilibriums, the mixture contains this SCN negative. The concentration is 1.3 times 10^-3, and the product is 0.3 times 10^-3 mole per dm cube. Okay, part 1. Calculate the initial amount of iron 3 which added to the SCN negative to produce the mixture. Because it's already mentioned, equal molar amounts means they're going to start from the same mole, equimolar. And after that, they mix, and the volume is 25 cm cube. So let's say they start from the same concentration. We give X. Before that, we need to use ICE table to get or to understand the calculation. So ICE means initial, change, and equilibrium. So we just substitute the values or the concentrations that given in the question first. Okay, for the initial, we know that the product is 0 concentration, not yet formed. And at equilibriums, these are the concentrations that given. The concentration of the products is 0.3 times 10^-3. And the SCN negative is 1.3 times 10^-3 mole per dm cube. Okay, so from this information, we know that, from all this information, we know that these FeSCN2 positive, these products, its change means here is plus 0.3 times 10^-3. If the products here plus 0.3 times 10^-3, the reactants must minus the same amount, minus 0.3 times 10^-3, because their mole ratio is 1:1. And let's say, because we don't know the initial concentration of the reactants, so we just put X. And the amount of the iron 3 and this SCN negative, they are same. So we just put X for both. So if SCN negative minus this amount, the iron 3 also need to minus the same amount because they have the same mole ratio as well. And the concentration of the iron 3 at equilibrium also going to be 1.3 times 10^-3. If we want to get the initial concentration, means is this one, the X. So it's very easy now. We just need to add 1.3 times 10^-3 with 0.3, because this is the one that reduced. If we add the concentration of the iron 3 at equilibrium with the concentration that reduced, we will get the initial concentration. Right, means we just use 1.3 times 10^-3 plus 0.3 times 10^-3, the one that reduced. So we get the initial concentration. Once we get initial concentration, we can get the amount. Very easy, we just use this one. N equal to mV/1000. M is concentration, V is a volume, 25 cm cube. Okay, so you just substitute the concentration that obtained times 25/1000, you get this mole. So 4 times 10^-5 mole. Okay, after that, then it's easy. Once you get this the concentration means the this concentration at equilibrium, right? These three, so we use this one, 1, 2, 3. So we just substitute the concentration, these two concentration to the Casey expression, we'll get the answer, right? So just substitute 0.3 times 10 power negative 3 over this 1.3 times 10 power negative 3, okay, square. So we get 178. And of course, if you want to get the units, so it's mole per dm cube over mole per dm cube square. So means you get per mole dm cube later, right? Just okay. So therefore, you get this 178 and this unit, right? So this one just cancel out, right? So cancel out, you get per mole and dm cube. Okay, that's all. Thank you.